this problem it is given that matrix A 2 1 1 2 and also a relation which is P inverse AP is equals to diagonal matrix D1 comma D2. Now let us look into this relation. P inverse AP is nothing but a diagonal matrix. Now if it is a diagonal matrix, then P power n will be always P. Now in this problem it is given that x and y are independent variables. Independent random variables, and we have to find expectation of y by x. Now we know that expectation of y by x is nothing but a constant, that is y, so it will be expectation of y. So the answer is option A. In this problem it is given that y is equals to root over x power 10 plus root over x power 10, so on up to infinite terms. Now we have to find the derivative of this, that is dy by dx. Now there are two ways of solving this problem. One is directly by formula. If y is a function which is root over f of x plus root over f of x plus so on up to infinity, then dy by dx is nothing but differentiation of the function f of x by 2y minus 1, which is dy by dx of f of x, which is x power 10 by 2y minus 1. If I differentiate x power 10, it is 10 into x power 9 by 2y minus 1, which is option A. And the other method is take this y root over x power 10 plus root over x power 10 plus so on up to infinity. Consider this entire term as y. Y is equals to root over x power 10 plus y. Now squaring on both sides. After squaring, differentiate them, you will get the answer as A. In this problem, a function f of x comma y is given as 4xy minus x square minus y square. Now we have to check whether it has maximum, minimum, or neither maximum nor minimum. Now, in order to find that, first we need to find fxx, fyy and fxy. Now here fx is nothing but 4y minus 2x and fxx is nothing but minus 2. Similarly fyy, if I differentiate the function twice with respect to y, it will be minus 2. And fx is always already we know 4y minus 2x, and fxy, if I differentiate, it will be 4. Now let us take the relation fxx into fyy minus fxy whole square. If this is less than 0, then the function will have saddle point. Now let us substitute the values. Minus 2 into minus 2 minus 4 square, which is always less than 0. So the function has saddle point. So the answer is option A. We have to find the integral of dz by 1 minus z minus 1 whole cube over the curve mod z is equals to 2. That is nothing but a circle whose radius is 2. Now, in order to find this, first we have to find the residues at z is equals to minus 1, as well as we have to find residue at z is equals to 1. Now, residue at z is equals to minus 1 is nothing but 1 by z minus 1 whole cube at z is equals to minus 1, which will give you minus 1 by 8. Similarly, residue at z is equal to 1 will be also 1 by 8. Hence, the required integral is nothing but 2 pi I into summation of residues at pole, whatever the number of poles, which is nothing but 2 pi I into 1 by 8 minus 1 by 8, because they are minus 1 by 8 and plus 1 by 8, which will be equals to 0. So the answer is option A.
To the counter, if the input frequency is 1.2 kilohertz, then the output frequency is. See, the counters are going to be in clear, or the counter is going to be resetted if Q1 bar as well as the Q0 bar both are going to be zeros. Then only the counter goes back to 0 0 0. Initially assume Q2, Q1, Q0, which is equals to 0 0 0. For the first clock pulse, it is going to be this. For the second clock pulse, it is going to be this. For third clock pulse, it is going to be this. For this particular combination, Q1 bar is 0, Q0 bar is 0. Hence, the output of OR gate is going to be 0. There is no need of extra clock pulse to clear the counter, because this is a combination. As long whenever the inputs appear across this, then it is going to clear the counter. Hence, from here to goes back to here. So how many distinct states are there means only 3 states. Hence 1.2 to 1.2 divided by 3, that is 4. That is option A is correct. That is, this is 0.4. One is set if M5 and M4 are 1, the range of addresses for which A1 is set. That is A0, this is A1, A2, A3. Here the address range from the options, it is a 16-bit address. So M50 to M8 are all ones. Here M15 to M8 are all 0 because they haven't given any connections about the M15 to M8. But remaining M7, M6, M5, M4, M3, M2, M1, M0. See, for the combinational circuit to enable, M7 and M6 must be 1. Then only combinational circuit is going to be enabled. So M4 and M5 must also be 1 in order to set A1 line. So this combination should be always in this way. Then only the combinational circuit is going to work and the A1 line is going to be set. The M3 and M2, M1, M0 can be varied in this range. So it is F0 to FF, this lower byte. So complete address range is 00F0 to 00FF. Hence option B is correct. In 8085 microprocessor system with memory mapped IO, which of the following statements are correct? Statement P, IO devices has 16-bit address. It's true because in memory mapped IO, the part of the memory space is allotted to the IO devices. Hence, the memory address is 16-bit. Hence, IO device is also going to have a 16-bit address. And the IO devices are accessed using in and out instructions. In and out instructions are used in IO mapped IO, not in memory mapped IO. So, hence, statement Q is wrong statement. Statement P is correct statement. There can be a maximum of 256 inputs and 256 output devices, because this is a wrong statement, because in case of IO mapped IO, the output address is 8-bit. Hence, we can connect 256 maximum input and 256 maximum input devices. But this is the memory mapped IO. It's not. This is a wrong statement. Statement is arithmetic and logical operations can be performed directly with the IO data. Here, this statement is correct because the memory space is allotted to the IO devices. The logical and arithmetic operations can be performed with the memory space. Hence, we can perform directly with the IO device as well because it uses the memory instructions. Hence, statement P and S are correct. Hence, option A is correct. Following circuit, the transmission parameter C is nothing but I1 by V2, I2 equals to 0, means the output port must be in open circuit mode in order to calculate the parameter C. So V2 is nothing but 5 into I1. I1 by V2 is nothing but a C, which is 1 by 5. Hence option C is correct. Type of the network acts as C at omega equals to infinite, means at infinite frequency the capacitor acts as a short circuit. Hence V out is going to be 0. At omega equals to 0, capacitor acts as a open circuit, means V out is nothing but a V in. Hence, if we plot frequency versus V out, the magnitude versus the frequency plot is going to be like this. Hence, it is kind of a low pass filter. Hence, option D is correct.